So in this revised syllabus, chapter number 1 and 2, 3, 4, 5 combined together 23 marks. Chapter number 6, 7, 8, 17 marks. Chapter number 9, 10, 11, 12, 13, 20 marks. Oscillation and waves 10 marks. This is the mark distribution. Okay, based on mark distribution, the question paper will come after the Pongal holidays. For you have a term end exam, terminal exam. You can prepare it. And first chapter just for the knowledge and give me important for the unit chapter number 2 to all the chapters. During revision time, I will tell you what are the areas important, how to prepare it, everything. For the portion completion, I will tell you chapter number 4, all the chapters are completed. Chapter number 15 only, almost I will try to complete today. Okay, now we are discussing the principle of superposition of wave.
The principle of superposition of waves. According to the principle, overlapping waves add algebraically to produce a resultant wave or net wave.
Please take a notes now. And draw the diagram also. For example, this is circular design. No? It is above S 2 centimeter, and one more wave also it is in downward direction. That also 2 centimeter. What is the resultant? It is zero. The resultant velocity, sorry, the resultant displacement, it is equal to zero. We'll discuss one by one.
Or net wave. In other words, when any number of waves met simultaneously at a point in a medium, the net displacement at a given time is the algebraic sum of the displacements due to each wave at that time. For example, let us consider two waves traveling together along the same stretched string in opposite directions. They met and passed through each other and move on independently as shown in figure. Each picture depicts the resultant wave form in the stream at a given instant of time. The principle of superposition of waves imply that the overlapping waves do not in any way alter the travel of each other. In mathematical form, suppose y1 of xt and y2 of xt are the displacements that any element of the stream would undergo if each wave traveled along. When the two waves overlap, the displacement y of xt of one element of the string would be given by yxt equals to y1 of xt plus y2 of xt. In general, it is the wave functions of the moving waves. 1. y1 equals to f1 into x minus vt. y2 equals to f2 into x minus vt, and so on. yn equals to fn into x minus vt. Then the wave function describing the resultant disturbance in the medium is y equals to y1 plus y2 plus so on plus yn equals to f1 into x minus vt plus f2 into x minus vt plus so on plus fn into x minus vt equals to sigma I equals to 1 to n of fi into x minus vt. To illustrate the principle, let us consider two waves of same angular frequency. W equals to of 2 pi by t. Same angular wave number. K equals to 2 pi by lambda. Same amplitude. Are traveling with the same speed along the positive direction of x-axis. If the two waves, one out of phase by a constant angle q, their equations can be written as y1 of xt equals to r sine of omega t minus kx. y2 of xt equals to r sine of omega t minus kx plus phi. According to superposition principle, the net displacement of the resultant wave in y of xt equals to y1 of xt plus y2 of xt equals to r sine of omega t minus kx plus r sine of omega t minus kx plus phi. Using the trigonometrically relation sine alpha plus sine beta equals to 2 cos alpha minus beta by 2 into sine alpha plus beta by 2. We get y xt equals to 2r cos phi by 2 sine omega t minus kx plus phi by 2. Equation 1. This equation shows that the resultant wave is also sinusoidal wave traveling along the same positive direction of x-axis. However, the phase angle of resultant wave is phi by 2, wrt. Either wave and its amplitude is r equals to 2r cos phi by 2. Equation 2. If phi equals to 0 is the two waves are phase in, then from equation 1, equation of resultant wave is y of xt equals to 2r sine of omega t minus kx. The amplitude of the resultant wave is 2r, which is largest possible as shown in figure. If phi equals to pi, that is, the two waves are out of phase by 180 degrees, then from 2, the equation of resultant wave is y of xt equals to 0. This is shown in figure. Three important applications of superposition principle are 1. Stationary waves. 2. Beats. 3. Interference of waves. The principle of superposition applies equally well to electromagnetic waves. For example, radio waves of many frequencies pass through a radio antenna. The electric current setup is antenna by the superposed action of all these waves are very complex. Nevertheless, we can still tune to a particular station, the signal that we receive from it being in principle the same as that which we would receive if all the other stations were to stop broadcasting. Likewise, in sound, we can listen to notes played by individual instruments in an orchestra, even though the sound wave reaching our ears from the full orchestra is very complex.
Please take a notes now for in this point. Okay, one small recap. We start with waves. What is wave? It is a kind of disturbance. The waves of three types. One is a mechanical wave, another one electromagnetic wave, next one matter waves. So mechanical waves, it is a two type, transfer wave, another one longitudinal waves. Mechanical wave needed for medium, electromagnetic wave no need for medium, it will travel in vacuum also. For example, electromagnetic wave, gamma ray, X-ray, ultraviolet, visible light, infrared, radio wave, microwaves. And the matter waves means it is a moving particle like electron, proton, neutron, subatomic particle also. And the transfer waves, another one longitudinal waves. Perpendicular direction. The oscillation of the disturbance is perpendicular direction means it is a transfer wave. It is the same propagation and the disturbance also same direction means it is a longitudinal wave. And this is some important terms and related to waves: amplitude, time period, wavelength, frequency, angular frequency, wave number, the propagation constant, k value, k is equal to 2 pi by lambda, velocity formula, v is equal to lambda by t, lambda into f, that is the frequency, omega by k. This is very important equation. The equation of progressive wave, which traveling along the positive x direction when initial base is 0. Then you will get y is equal to a sine omega into t minus x by v. A referred amplitude of the wave, v is the velocity, otherwise speed of the wave. Kindly note the formulas, it is important. Y is equal to a sine omega t minus omega x by v, and what is v? That is omega by k. Just to replace, you will get y is equal to a sin omega t minus kx. Maximum in this lesson, they will ask question. For example, y is equal to 2 sin 1 minute more. Y is equal to 2 sin 0.5 t minus 7x. So based on equation only you want to understand, okay, the value of a, that is a 2, the value of omega 0.5, the value of k, that is 7. Like that you want to take from the general equation. So you want to remember maximum number of formulas. Next formula, y is equal to a sin 2 pi small t by capital T minus x by lambda. Capital T, that is a time period, T is the time, and the lambda means wavelength of the wave. It is a constant, omega value, k value, and v value. All the things you want to remember. That is a positive direction. Now, the progressive wave traveling along negative x direction. So negative means that is a positive. In center will come plus, and initial base value it is 0. All the derivation part we already completed. Kindly refer the before class notes. Then only you know about all the equation, how it is coming, everything. And one more formula, y is equal to frequency t minus x by v for the base equation omega t minus kx. For the initial base, the value of x equal to 0, t equal to 0, and y also 0. That is the initial base. In case y not equal to 0 means the initial base also non-zero. This is related graph oriented a sin omega t minus kx minus pi. Particle velocity formula Vp equal to dy by dt. The y formula, y means displacement, a sin omega t minus kx. Do the differentiation, you will get a omega cos omega t minus kx will come. So it is a maximum omega a. Next to particle acceleration, d square y by dt square. Two time you want to do the differentiation, then you will get minus omega square y. See here, a omega square sine omega t minus kx it is there. What is y? Y is equal to a sine omega t minus kx. So just I replace it, I will get minus omega square y. For the maximum, minus omega square a. Okay, next one, the important characteristics of wave. So what are the characteristics? The base of particle of medium change with the time. The velocity with which the particle moves is different from the velocity of waves. It is independent of frequency and wavelength of wave. Related wavefront we will discuss next year. That is a different track wavefront and the source on all particle of a medium are in the same base means it is called as wavefront. Okay. Sound wave, it is a longitudinal produce a sensation of hearing. The range of sound wave 20 Hz to 20,000 Hz for human, 20 Hz to 20,000 Hz. Below 20,000 Hz, below 20 Hz means it is infrasonic sound. Above 20,000 Hz means it is ultrasonic sound. In ultrasonic sound, applications also there. In our day-to-day life, many applications it is a health department, industry department, and defense department. Maximum, we are using the ultrasonic sound. So speed of sound in the different medium for the longitudinal wave for the solid, y referred Young's smallest, rho means density of material, the speed of transfer wave in string v is equal to root of t by mu, and what are the relation for the t, rho and d. D means diameter of the wire. The terms of Young's modulus they are asking means you can use in this formula. V is equal to y by rho into strain. Next formula, the speed of sound in gaseous. So gaseous, it is a bulk modulus B, B by rho. Applying the constant value, we will get 280 meter per seconds. For the velocity of sound in the air, standard condition 332 meter per seconds. In morning we discussed Noma, the Doppler effect. The Doppler effect V formula it is no. In this V, the value is 330, sometimes they will give 340 based on the question. See here. The factors affecting the velocity of sound in gaseous, pressure, density, temperature, humidity, the effects of wind. So this is the characteristics of sound, frequency, intensity, waveform, or quality. For the reflection of waves at the boundary, right boundary means you can use in this formula. After reflection, it will add with the pi. Open boundary, same y formula. Y is the displacement formula. After the reflection, the y dash equal to a sine. The minus will opposite direction. It will come positive. The relation between base difference, path difference, and time difference. It is also one important one more question. Del pi by 2 pi equal to del x by lambda equal to small t by capital T. Base difference, path difference, time difference. Now we discuss the now superposition of wave principle. The displacement of resultant wave at the point is the vector sum of the individual displacement of separated wave present simultaneously at the point. So this is the definition. Standing waves and stationary waves is one of the application. I will take two set of progressive wave, same frequency and amplitude, and the same path in the opposite direction. The resultant wavefront only expand and shrink. It is called a stationary. To a cos kx. This is entire value is considered to the amplitude of resultant wave. Okay, organ pipe we will discuss after this.